Hello everyone, I'm just going to give you an example of how a geometric series question might look when it's related to the real world. Alright, so this is an investments problem and you've got this person, Sal's. She invests £700 into a bank and she's doing that at the beginning of each month. So it says at the start of the year, Sal's invests £700 in a bank and she invests a further £700 at the beginning of each subsequent month. So January, February, March, April and so on, she's always putting £700 into her bank account. Now, the bank, because it's an investment, is giving her interest on this. The bank is given, in this case, 3% interest, and that is paid in at the end of each month. So before we read on, let's just work out how much she'd have at the end of the first month, shall we? So at the end of the first month, she's investing £700 at an interest of 1.03, 3% interest, multiplied by 1.03, you get your investment at the end of the month. Now, we don't need to work out what that is, okay, as long as just we don't. Okay, it's going to be a number, of course, but we don't really need to know what it actually is, as you'll see in the context of the question. So that's our calculation for the end of the first month. Let's read on. How much will be in the account at the end of the year? So we've got to see how much it's going to be at the end of 12 months. That's 12 months in 1 year. The way to do this is just to build it up slowly. Having considered what's after 1 month, let's see what happens after 2 months and 3 months and so on until we see what the pattern is. And that's generally how you solve a lot of mathematical problems. You build it up slowly and see what is going on. See what, in this case, the pattern is. So we'll see what happens after 2 months, shall we? Let's just do some work in here. Okay, so 700 times 1.03, that's how much she's got at the end of month 1. What's going to happen is she's going to invest another 700, okay, and she's going to get interest on that. Because she gets interest on all of that, put it in brackets, multiplied by 1.05. So that is our calculation for how much Sal's will have at the end of the second month. That's just written more neatly there. Okay, so I'm just going to get rid of that now. And you can expand the brackets. So 700 times 1.03 times 1.03 gives you 700 times 1.03 squared and 700 times 1.03. Okay. Again, you don't need to work out what that is. The thing is, if you do work out these values, you get awkward numbers, you're not going to see what the pattern is. Okay? There's no way you'll see what the pattern is. So I suggest you just keep it like this. That's the reason for setting out the working like this, by the way, so you can spot what the actual pattern is. And hopefully you'll see there's a rather simple pattern. Now, what you can do is you can rewrite it. Notice the 700 here and here, you can factorise with the 700. Okay? And I've done that in my next line. So factorise means set of brackets, 700 in front of the brackets, and then inside the brackets 1.03 squared plus 1.03, check. When you expand the brackets, you get that line there again. Okay? So that's after 2 months. Ooh. Let's see what happens after 3 months, shall we? So after 3 months. So what I'm going to do is I'm just going to build it up slowly, okay? So taking this line here, yeah, because it's just convenient because it's got no brackets in it. Each month, Sal's is putting an extra 700, so you always add 700 and then multiply everything by the interest, 3%, 1.03. So that's our calculation. And I've just written it neatly just by there. Okay? And then what we're going to do is just expand the brackets like we did previously. So I'm just going to get rid of that now. Expand the brackets, you've got 700 times 1.03 cubed, plus 700 times 1.03 squared, plus 700 times 1.03. So that line by there. And then I'm going to do the same as what I did before. I'm going to factorise. This bit's crucial because it will help us to solve the problem in the end, okay? So you've got 700 there, there, there. And what that means is because you've got a common factor of 700, you can factorise this 700 outside the brackets. And you're just left with that there, 1.03 cubed, 1.03 squared, 1.03. Okay. Do remember, at any point, you can pause the video and just think about it, or just replay the video. That's the advantage of these videos, I find. In the classroom, you can't do that. You can ask me again, but obviously in the class, it's not the same as if you're actually watching it on your device and you can just think about it in your own time. Right, I'm going to summarise that here. Like that. Okay, so basically our end results here. I'm hoping you can spot a pattern. Okay? If you want to practice more, so if you want to work out what happens after 4 months, then the thing to do is take whatever you had after 3 months, okay? Whatever you had after 3 months, you always add 700 and then multiply that by 1.03. That's the mathematics of it. Always add 700 times by 1.03. But when you simplify it, hopefully you'll spot what you'll get. You'll get 1.03 to the 4, 1.03 cubed, 1.03 squared, 1.03, all times 700. After 12 months, I'm hoping you can see what the pattern is now. You've got 1.03 to the power 12, plus 1.03 to the power 11, and so on down to 1.03. All multiplied by 700. The 700 is important because that's the investment at the beginning of each month. Okay, so we're always multiplying by 700. This is a geometric series now. Okay, that's the relevance with geometric series. If you ignore the 700 in the brackets here, if you start at this end, A, your first term, 1.03, multiply each term by 1.03, so your common ratio R is also 1.03, and there's 12 terms. So that's your geometric series, all multiplied by 700. Okay, so that is summarised here, exactly the same line. All we need to do now is use our formula for summation of geometric series and work out what it is. I've chosen this one because R is, let me write it down again, R is 1.03, and when I use that I get a nice number in the denominator, not a negative, and I'm just going to use A equals 1.03, N equals 12, and you'll get this. Not forgetting, of course, about the times by 700. Now, you've got a choice. You can either work out what that is, and then times by 700, get your answer, or if you wanted to, you can work out 700 times 1.03, because you're multiplying, it doesn't matter either way. Okay, that's how multiplication works. You can multiply at the end or at the beginning, you'll get exactly the same answer. If you do 700 times 1.03, let me just do it for you, you get 721. So if you've got number 721 somewhere, that's what's happening, okay? Just going back to this, if you worked out what that is, that would be 721, okay? But as I said before, if you work out what that is and what that is, you're not going to see the pattern, okay? It's crucial that you see the pattern of the 1.03s and the increasing powers. Otherwise, you're not going to get what the common ratio actually is, 1.03. And then when you work out what that is, because it's money, that's 2 decimal places, £10,232.45. And that's your answer. I'm hoping that made a lot of sense to you. I'm hoping you can see why this is a useful problem to have, because if you want to invest some money because you're saving up for something, holiday, car, luxury item, doesn't matter what, okay, house, apartment, you've got a certain amount of money that you're able to invest from your earnings each month. You can work out how much you'll have at the end of each year or each 2 years or whatever. All you need to do is just change that to how much you're investing. So suppose you invest 1,000, and that will become 1,000. Suppose you're doing it over 24 months, it'll be up to the power of 24, so you use n is 24. And if the interest rate is different, you just adjust it. If it was 6%, 1.06 instead. So it's a very handy generic formula that you can use. Right, I'm hoping that that was useful to you, and I'm hoping that you understood it all. Thank you very much for watching. I'll see you again. Bye.